So let's go to the different techniques of integration. So what we have discussed so far are just the um, those are just the formulas that we have discussed for the past few meetings. So up until the exponential function. So as you notice, you are given formulas of integration. But this time, we're going to venture into the different techniques of integration. So these techniques will be applicable if you are presented with complicated equations, such as combinations of two functions. For example, one is algebraic, um, the other one is trigonometric, and then ano siya, so vice versa na siya. So there are four techniques, and we're going to discuss the first one, which is algebraic substitution. So next meeting is trig sub, and then integration by parts. Then lastly is integration by partial fractions. Okay, so don't worry for those who cannot join. So I'm still going to upload this recording in the Canvas platform. Okay, so let's go to the algebraic substitution. So if you're going to read the whole statement, just try to read the ones on the statements or the phrases being underlined. So notice in algebraic substitution, we're going to introduce a new variable of integration in place of the original variable. So what does this mean? So mura siya kanang kuan, di ba? Mura siya u sub, but um, instead of using u sub, so I think the, the the technique of algebraic substitution is more like the same as the u sub technique, but what we're going to replace is a complicated parameter. So usually in algebraic substitution, we're just dealing with algebraic terms, and mostly terms being expressed as radical expressions. So for example, mga x, cube root of x, mga inana ba? So puro siya algebraic, meaning they're all in terms of x variables. The expressions are all in x parameters or probably y parameters depending on the variable that is presented on the problem. So mana siya. So most likely what we are going to see in our problems are expressions in algebraic, but um, combined with radical expressions, kind of mga square root, mga cube root, so on and so forth. Okay, so there's no general rule in this technique, so it only requires practice. So you inspect the integrand, and then after some inspection, um, you do some algebraic substitution, and then you go with the process of the same as the u sub technique. Then afterwards is ano siya? Excuse. Okay, so I think my number one tip here is for this statement. So since we're going to replace a certain original variable, so what we're going to replace or what we're going to substitute is the complicated term. So same as the u sub, we're going to replace the complicated term, but most likely what we are going to replace here in algebraic substitution are radicals. So what do you mean by radicals? So again, these are the square roots. Nth root, square root, cube root, fourth root, so on and so forth. Okay, so for you to appreciate this particular technique, uh, let's go to some examples. But again, in this technique, instead of using u, we're going to use z now, z, as our main variable of replacement. So ano z man, because later on, for example, you're going to use z first. So in some problems, after using z, we're still going to use another u sub technique during the process of integration. So ang z mahimong u na sad na. So murag kaduha mo mag-replace a variable. So that's the idea of why we are using another variable of integration. Okay, so we have 7. So let's try to discuss the 7 examples as we move along. So notice that um, if you see the examples, so most of the examples have radical expressions and all terms are expressed in algebraic function, di ba? So x, then 1 plus x. So you only have mga radicals lang sa inyong algebraic functions, di ba? Such as this one, then this one. And notice you have square root of x minus 4, then others have fifth root, then cube root of x plus 1, cube root of x squared plus 1, then square root of x, then cube root of x. So if you're encountering this problem, so most likely you're going to approach this as the technique in algebraic substitution. Okay, I think if you're going to use natural U sub, so marag mababoy mo dito sa inyong solution, di ba? So for example, we're going to let u here as 1 plus x. Then the du here is dx, di ba? So you have here dx as du. This one becomes u. So how about square root of x, di ba? So mana maglisod ta og kanang ko magbalik-balik ra na siya. So for example, if we still if I isolate x, so x equals u minus 1. So this becomes square root of u minus 1 gapon. So there's nothing um, there's nothing achieved in the u sub technique, diba? It just keeps on getting complicated. Magsigar rotate ang inyong kuan. So always remember that the A of the u sub technique is for you to simplify the equation, not to complicate it further. Okay, so let's try the first example. So we have here the square root of x over 1 plus x dx. So again, in u sub, we're going to most likely replace the term in the radical expression. So z is equal to square root of x. So again, for us to eliminate the square root, so we have to square both sides, diba? So meaning we have to square both sides, diba? Square. So this is going to be z squared is equal to x. Okay. Then after this one is we're going to derive the whole equation. So the left side becomes 2z dz, right? So bring down the exponent, then minus 1 exponent, and then dz. And the right side is just dx. So notice that that we can replace the different terms inside the equation. So for square root of x, this becomes the z parameter. For dx, this becomes the 2z dz term. And for 1 plus x, so of course we just replace x variable as z squared. So ana ra siya, mura siya the same as the u sub technique, but we're just adding some steps like deleting the radical expression. So I think mura na siya ang bago sa akon. Okay, so if we try to replace the terms now, so again, square root of x becomes the z parameter now. So ako lang i-parenthesis ha para inyong ma-track down ang mga terms later. Dx, so again, dx is now 2z dz, then divided by 1 plus z squared. Okay? So this becomes 2 integral of z squared dz all over 1 plus z squared. So how are you going to deal with this now? So notice that the exponent of the numerator, the degree of the numerator, is the same as the denominator. So meaning we can use long division for us to simplify this one further. So let's try another color para inyo makita ang separate na solution for this one. So long division, 1 plus z squared. Marag di maklaro, no? Then divided by z squared. So this should be 1. This should be z squared plus 1. So minus, di ba? Then you have negative 1. So again, you express your answer as the quotient and then plus the remainder. So that would be the remainder all over the divisor. Okay? So going back to the equation. So our equation now is 1 minus 1 over 1 plus z squared. So you have 2 integral of 1 minus 1 over 1 plus z squared dz. Okay, so if we separate the two functions, so of course don't forget to multiply 2 to each term. So of course the purpose of me separating this one is for you to be able to see two expressions. Okay, probably the next terms are a bit complicated compared to kanang inyo lang imano-mano o integrate. So 2 integral of dz and then minus 2 integral of dz all over 1 plus z squared. So probably the first integral is just simple since you're just integrating dz. But for the second term, so medyo matag maglibog, di ba? But simple din siya because this one is arctangent. So remember the format for arctangent equation. So if it's a squared plus z a if it's a du all over a squared plus u squared. So our a squared is the one here, diba? So let me try to express this para makita. Mas similar to du all over a squared plus u squared. Okay, so what we have here is 2z minus 2 arctangent z plus c. So it should be 1 over a, but since our a is 1, so there's no need for us to put over 1. Okay, marag redundant na kayo, di ba? So of course, don't forget to bring back the value of your z parameter, which is square root of x. So this becomes 2 square root of x minus 2 arctangent square root of x plus c. Okay, so questions? Okay, so I think it's clear, di ba? Okay, so let's move on to the next example. So for a while, class akin. Okay, so sorry about that. So let's move on to example number 2. So again, we try to replace square root of x. So again, probably you're going to ask why we're going to use directly the algebraic substitution technique. So again, if you try to do the simple u sub technique here, so marag impossible kay siya, di ba? To replace every expression in the equation. So that's why the other technique is algebraic substitution. So I think my tip here is if you see directly a radical expression, just go directly to algebraic substitution technique. So ana lang siguro siya para dili mo maglibog unsay gamiton ako. But take note that even though that there are radical expressions in some examples, probably those examples might be solvable through simple na u sub, di ba? So just try to examine the integrand given in the equation. Okay, so we try to replace this one. So again, this will be z equals square root of x. Then this becomes z squared. So squaring both sides to eliminate the radical expression. So again, our radical expression are the square root terms or the root terms. Then this becomes x. So next is you integrate, or rather we derive. So this becomes 2z dz equals dx. So again, first step is we declare the square root function, the root function as the z variable. And then next is we try to eliminate the root function. Then next is we derive. So of course, fourth step would be to replace the terms above. So dx becomes 2z dz all over. So our x is this term here, z squared, and then minus square root of x is z. Okay, so notice that we can still simplify further the equation. So let's try removing the constant outside. The numerator becomes z dz, and then the denominator becomes, so we can factor out one z, so z times z minus 1. So cancel out one z in the numerator and in the denominator, and this gives us 2 integral of dz all over z minus 1. So if you come across this equation, so you might feel a bit kanang cornered, or let's say trapped in this particular equation, but this one is just pretty simple. So again, the purpose again of using the z parameter is for us to be able to use another, or we can still use sub technique without further confusion in our solution, kay para dili po siya pareha, dili siya puros u tanan, di ba? So this time is we're going to use the u sub. So let u is equal to z minus 1. Getting the derivative, this becomes dz. So notice that every term can be expressed as a new variable. So this becomes 2 integral of du all over u. So notice that this one is a basic formula which gives us the integral of ln. Diba? So this gives us 2 ln u plus c. So of course, this is not yet the final answer. We have still to replace the u parameter. So this becomes z minus 1 plus c. And lastly, to replace the z parameter, which is square root of x. So the final answer is 2 ln square root of x minus 1 plus c. So that's the final answer. So medyo dali na kayo siya, di ba? So questions or clarifications? Okay, so I think there's no question. Probably you guys are still kanang feeling the Monday blues, di ba? Kanang wala pa kahunat ba? Okay, start of the week pa. Sige lang. So just try to review the recording later. Okay? At least there are examples presented in the recording. So you might see this one as a different discussion sa inyong Canvas platform. So ang katong nasa inyong modules in the Canvas platform was created by the EM coordinator. So probably magbangga siguro among pag-declare sa mga variables, but just try to follow my kuan lang siguro solution para di mo maglibog sa inyong kuan. Okay, so next is this example. You have the uh, the, the integral of x cubed. So the cube here is towards the x variable, not towards the radical expression. Then square root of x minus 4. So again, we need to replace the radical expression with the z parameter. So algebraic substitution. So algebraic siya, di ba? Kay z is still algebraic function. So any variable, so pwede mo magbot-bot og inyo og di mo ganag z parameter, so you may use another type of variable as long as it's a variable or it's a letter, di ba? So this is square root of x minus 4. So again, getting the square of both sides. So this is z squared. Then you have x minus 4. Then getting the derivative, we have here 2z dz and then equals dx. So we already can replace so we can replace the square root of x minus 4 as z. We can replace dx as your 2z dz. So how about x cubed or x variable? So where can we get the x variable? So we can borrow it from here. So we can isolate x parameter. So x equals z squared plus 4. So this term here is going towards here. Murag manipulate ra sa mga terms available. So this time this becomes the the integral of z squared plus 4 cube, and then square root of x minus 4 becomes the z parameter, and then dx is 2z dz. All right? So next is we're going to expand this one. So hopefully you still know your algebra, atong inyong basic algebra. So expanding cube binomials. So probably if you forgot how to expand this one in a fast manner, so muna inyo sang imano-mano, inyo siyang inaani og style ba? Like z squared plus 4, z squared plus 4, z squared plus 4 times z yana murag taas-taas siya ba, di ba? Now, so you have to multiply this one first, and then the product of this one you multiply with the next z squared plus 4. So if you want a faster pace nga kuan, so try to use Pascal's triangle. So for those of you who don't know what is Pascal's triangle, so I think this is the katong kuan, katong shortcut in determining the coefficients of higher order nga anong kuan, expansion sa inyong binomials. So di ba naman to, di ba? 1, 1, 1, 2, 1. So this is the quadratic, di ba? To the power of 2, second degree. Then 1, 3, 3, 1, di ba? This one is the third degree. Third degree nga polynomial na, di ba? So again, ano na kuan siya. So for those of you who don't know, so for example, you have a plus b squared. So this gives us a squared plus 2ab plus b squared. Nato, di ba? So coefficient here is 1, 2, 1. So here is we're going to have a cubed plus a squared 3a squared b plus 3ab squared plus b squared, b cubed rather. Sakto, di ba? So if you know that shortcut, so you can just proceed to that shortcut directly. So a cubed, so this becomes z to the power of 6 plus 3 times a squared plus b, that would be 12. 3 times 4, that would be 12. 12, and then z to the power of 4, z squared squared is z to the power of 4. Then plus 3ab squared. So 3ab squared, 3 times, so 16 times 3, that would be 48, z squared. Then lastly is 4, 4 cubed, that would be 64. Then try to simplify this one also. So 2z dz. So 2z squared dz. So try to check if this one is correct. So I just use Pascal's triangle for me to be able to determine the shortcut method of expansion sa binomials. Okay, so we have to multiply again with 2z squared to each term. So it's going to be 2z to the power of 8 plus 24z to the power of 6 plus 96 z to the power of 4 plus 128 z squared and then dz, di ba? So pili na niya dz. So I think you can integrate this one manually since the individual terms in the equation are all simple. So you can just use power rule. So this gives us 2z to the power of 9 over 9 plus 24 z to the power of 7 over 7 plus 96 z to the power of 5 over 5 plus 128 z cubed over 3 plus c. So medyo taas kini siyang answer because you still have to replace the z with this term. Okay, so may express this one as fractional form para di mo maglisod. Or pwede sad ninyo i-square root lang, ana, para di mo maglisod sad. Pero sa kuha, mas dali siguro siya if inano siya pag-express. Like, x minus 4, then 9 halves all over 9. Plus 24 x minus 4, 7 halves all over 7 plus 96 x minus 4, 5 halves all over 5 plus 128 x minus 4, 3 halves all over 3 plus c. So pwede rin siguro na siyang answer, but if you try to look closer in the equation, you can still simplify this one, di ba? Pero mas mataas lang inyong answer. Okay, pwede pa nyo makuha og certain root ang inyong express nga equation. Alright, so I think the problem later on will be the expansion, the definition of the operation signs. So be careful with those as you try to progress with your calculations. So questions for example number 3. Okay, so no example, no questions rather. So let's go to example number 4. So this time we have x times the fifth root. So this is the index of the square root function, di ba? Itong inyong mga parts sa different parts sa inyong radical expression. So this is the index, meaning that is the root being expressed in the radical function. So the fifth root of x plus 1 squared. So saan na siya pag-deal? So again, we try to eliminate the radical expression. So if you're going to express this one in exponential form, meaning kanang exponential form, exponent na form. So this would be x times x plus 1. Then this would be 5 halves dx. Or rather 2/5 there, bali. So 2/5 there, 2/5. So 2/5. Okay. So we're going to try to eliminate or try to replace this one with z. So 2/5 is radical expression, but regardless of how many exponents that the term has, whether it's cube or no power at all or to the power of 1 lang siya, as long as it's a radical expression, meaning it's under a root function, so we have to eliminate that particular term. So z is equal to x plus 1 to the power of 2/5. So how do you eliminate 2/5? So of course we try to multiply everything by to the power of 5 halves. Na bali, di ba? Kaya para ma-eliminate ito. So this becomes z to the 5 halves equals x plus 1. All right. And then getting the derivative. So let's try to put some arrow. So getting the derivative. So bring down the exponent. 5 halves. Z exponent minus 1. This becomes 3 halves is equal to dx. So notice that we can replace this one. So kanina itong given expression will become the z function. Dx becomes the 5 halves z to the power of 3 halves. So how about x? So again, we need to borrow the x variable elsewhere in the given expression. So from this point here, you can try to replace or isolate x. So this becomes x equals z to the power of 5 halves minus 1. So this becomes your x variable. So again, with just look for the terms in the process kay para di kayo maglibog. Okay, so replacing the terms. So x now becomes z to the power of 5 halves minus 1. And this becomes the z parameter. And then dx becomes 5 halves z to the power of 3 halves dz. Okay, so multiply, multiply, and then multiply. So in the first term, we're going to have z to the power of 5 times z times 5 halves z, or pwede na sa inyo tatawag na 5 halves kaya para di mo maglibog later. So you can try to opt it out in the equation. So this becomes 5 halves integral of z to the power of 5 halves minus 1 times z, and then times z to the power of 3 halves. Para di mo maglibog, di ba? Mas better siya. So z, so this is the power of 1, di ba? Z to the power of 1. So 5 halves plus 1 plus 3 halves. So again, this is the first term still. So this gives us 5 halves integral of, so 5 halves plus 1 plus 3 halves, that would be z to the power of 10. Kung 10 siya, ano 10 siya? Kamo na i-discover ano 10 siya. So I think it's a simple exponential rule siya. Properties of exponents, diba? So try to review that one. Next is the second term of the binomial. This one here. Then going towards the next term. So negative 1 times z to the 3 halves. So this becomes minus z to the power of 5 halves. And then dz. So we can now integrate the two terms using the exponential rule because the two terms are simple. So 5 halves times z to the power of 11 over 11 minus 5 halves multiplied by z to the power of 7 halves all over 7 halves plus c. So again, try to be quick with the fractions because I don't have time to elaborate further on simple stuff. Okay, dapat by this time you already have mastered those basic basic ideas. So this becomes 5z to the power of 11 all over 22, and then minus, so this becomes 5 halves, rather 5z to the power of 7 halves all over 7 plus c. So ang nawa man ng 2, so of course it will cancel each other out. And lastly is you have to bring back the value of the z parameter, which is x plus 1 to the power of 2/5. So this becomes x plus 1 to the power of 2/5 and then raised to the power of 11 pa dyan, di ba? Minus 5 x plus 1 raised to 2/5 to the power of 7 halves pa dyan. Na, di ba? All over 7 plus c. So power to power rule, di ba? power properties of powers. So multiply, di ba? So final answer would be 5 times x plus 1 raised to 11 over 5 over 22, or it's rather 22 din siya eh. And then minus 5 x plus 1. So cancel ang 2, di ba? So 7/5 all over 7 plus c. So this is the final answer. So murag correct ang ato ang answer because if you try to look at the exponent, 22 over 5, it's the reciprocal of the di ba? The constant 7 over 5, di ba? Reciprocal. So probably murag mo na yung hint if your answer is correct or not. Okay, so questions or clarifications? Okay, so there's no questions. So let's move to example number 3. So of course, so again, repetition na itong button. So z equals the cube root of x plus 1. So this becomes z cubed, then x plus 1. So if you're going to kana pwede mo maglibog, so you can try to isolate x directly. Na pwede mo magbalik-balik sa kuan. So x equals z cubed minus 1. Ana, so pwede sad. Then getting the derivative is you have, so same na sila. So either of the two, same na sila. So the purpose of this one is just to isolate x. Okay, now the x diri nga variable. So getting the derivative is you have z 3z squared dz is equal to dx. Okay, so this is our dx. We can replace it with 3z squared, then our cube root of x plus 1 to be replaced by z. So atong batang arrow para kita dyan. Okay? So this becomes, again, x is z cubed minus 1. Dx is 3z squared dz all over z parameter. So cancel out z, cancel out 1z here. So what's left is 3. So we can factor out 3 here. This is z. So since 1 na may denominator, so we can just try to express it in the middle. So z cubed minus 1 times z dz. So further expanding is we are going to have 3 integral of z to the power 4 minus z dz. So simple or basic formula. So this becomes 3z to the power 5 over 5 minus 3z squared all over 3 plus c. Rather, it's 2 there. Okay, so bringing back the value of the z parameter. So this gives us 3x plus 1. So ako lang i-shortcut ha. 5 cubed, 5 thirds all over 5 minus 3 times x plus 1 raised to 2/3 all over 2 plus c. So again, notice that the coefficients are reciprocal, di ba? Sa exponents. So meaning murag correct ang atong kan. Right? So questions. So again, if you're confused why it's 5/3, so just try to dissect it as much as you can. So one example would be here. So 3 times x plus 1 raised to the power of 1/3. Ana, 1/3 na siya una. And then to the power of 5 pa dyan, di ba? Power to power rule. Ana. So kamo na lang discover ana. Okay, it's very basic. Okay, so questions for example number 5. Okay, so no question. So let's proceed with the second to the last example. So we have here the integral of x cubed all over the cube root of x squared plus 4. So again, we try to eliminate the radical expression. So z equals cube root of x squared plus 4. So getting the cube, which is z cubed equals x squared plus 4. So again, if you want to isolate x squared directly, so you may do it so. So x squared equals z cubed minus 4. Then get the derivative. So either derivative sa 2 okay ra siya. Okay, it gives the same answer. So 3z squared equals 2x dx. Okay, so isolating x dx. So we have 3 halves z squared equals x dx. So notice that we have here x cubed, di ba? We also have z squared here. Then we have x dx here. So of course, ang kaninyohang kuan, the denominator can just be replaced directly with the z parameter. So how are we going to manipulate the numerator? So we can have it as x squared times x, di ba? Times x dx. So meaning x dx will be replaced by 3 halves z squared. X squared will be replaced by z cubed minus 4. So again, x squared is going towards here. X dx going towards this term here. Denominator going towards z. So again, x cubed here becomes the terms here. Sharo masaag po dyan, no? Nga daghan na kay arrow. So of course, in the real exam, just try to avoid encircling the equations kay para dili kay siya hugaw tanawon. So again, what I'm doing here is just for the sake of discussion. So um, in actual calculation, so just try to avoid using lines. So I think you can do the lines mentally. Na kung asa pa dong ni siya nga term, ana. Okay, so the equation becomes, so first is z squared, so z cubed minus 4. And then x dx. This is 3 halves z squared. So it's dz pa day, all over the z parameter. So taking one z out, so the equation becomes z cubed minus 4, and then 3 halves z dz. So we can further take out the constant. So 3 halves integral of z cubed minus 4 times z dz. So simplifying further, we now have z to the power of 4 minus 4z dz. So we can now integrate. So 3 halves times z to the power of 5 all over 5 minus 3 halves times 4. Di ba? Napamatay 4. So 4 times z squared all over 2 plus c. So cancel out 2, cancel out 2. So what's left is 3z5 over 10 minus 3z squared plus c. So don't forget to bring back the z parameter. So this gives us 3x squared plus 4, 5/3 all over 10. And then minus 3. So this gives us x squared plus 4 to the power of 2/3 plus c. So again, if you look at the exponent and the ano siya, so magdili siya similar, di ba? But of course, na murag wala siya, it's divisible by 2 because of the exponent of the given expression. Okay, x squared man siya. Yan, namataan ni dire. Muna siya nakapa divisible by 2 niya. Alright? So questions or clarifications? So I guess there's no question. So let's proceed with the last example. So after this, I'm going to post the assignment. So try to figure this one out. Kaning technique. So this time is you are given two radical expressions. So one is square root, the other one is cube root. So how are you going to do? How are you going to replace two different radical expressions? So okay na to duha ka box square root, diba? Or let's say tulo ka cube root, ana. But this time one is square root, one is cube root. So the technique here is you have to eliminate both once. I mean at one time. Meaning inyo siyang idungan o replace in one go. So unsaham na siya. So for example, this is z to the power of 1/2. I mean rather x to the power of 1/2. And the other one is x to the power of 1/3. So what we're going to do is we're going to get the LCD of this one. Or para madali mo, just try to multiply this one together, di ba? So this gives us x to the power of 1/6. Na, if di mo ganahan mo tanang ano, inani siya dapat, so i-multiply lang siya dito para di mo maglisod og sabot, di ba? So ano lang siya. So x to the power of 1/6. So meaning if we try to declare z as x to the power of 1/6, then multiply this one by the 6th power. So this becomes z to the power of 6 equals x. And then this becomes 6z to the power of 5 dz, and then equals dx. Ano siya? Okay? So the purpose of this having as x to the power of 1/6 so that we can eliminate both radical expressions in one go. So if you try to replace now the terms, so yun siya ma-observe nga murag nawala dito ang duha, di ba? So 1 all over. So again, square root of z to the power of 6 plus cube root of z to the power of 6. Then 6z rather to the power of 5 dz. So square root of z to the power of 6, this would give us z cube, di ba? Plus cube root of z to the power of 6 z squared. So numerator is 6z to the power of 5 dz. So we can try to simplify the denominator by factoring out z squared. So we can also factor out 6 z to the power of 5 all over z squared is z plus 1. So this becomes z cubed. This cancel out. So what remains is 6 integral of z cubed all over z plus 1 dz. So notice that the numerator is a bigger degree than the denominator, so we can use long division. So this gives us z plus 1 and then z cubed. So this becomes z squared plus rather z cubed plus z squared minus z squared, and then plus rather minus z there, minus z. So minus z squared minus z. So z pa, di ba? So basta ka mo lang ikaw long division na kay it will take some time jud if we're going to review some basic stuff. And then this one is plus 1. So z plus 1. Then minus 1. So minus 1 is tinatapidi ka kuan, di ba kay we don't have any further variables na. So this becomes 6 integral of z squared minus z plus 1 minus 1 all over z plus 1 dz. So just try to integrate this one further. So probably this one is 2z cubed minus 3z squared plus 6z minus 6 ln of z plus 1 plus c. So I think muna siya and then try to replace the z parameter afterwards. Okay, so questions for the last example. Okay, so I guess you don't have any questions. So probably after lunch, I'm going to post the assignment. Then the video is within the day kaya magtaas ang processing ni YouTube sa pag-upload sa video. Okay, so if you don't have any further questions, so I think that's it for today. See you on Wednesday.